computer. Okay. All right, so let's begin our review. Here's the first question. What's the next element in this sequence? You can put it in the chat if you want.
80.
80. Good. Everyone can say that it's going to be 80. And this is it arithmetic, geometric, or neither? This sequence, is it an arithmetic sequence, geometric, or neither? Arithmetic. Very good. It's arithmetic because we're adding 10 each time. Here's another sequence, 9, 18, 36, 72. What's the next element in this sequence? Does anybody know? What's the next element of the sequence? 144. Yeah, Julie, you got it right. It's 144. That's the next element of the sequence. And is this sequence geometric, arithmetic, or neither? It's geometric. Good. It's geometric because you're multiplying by 2 to get from the last term to the next. All right, here's another sequence. What's the next term here? Is it 58? I don't think so. It's not 58. 60. The next term here is 60. Why? Well, from here to here, you added 10. From here to here, you added 11. From here to here, you added 12. So next time, you're going to be adding 13. Okay, Daniel? So is this arithmetic, geometric, or neither? Neither. Good job, Daniel. Good. Here's another sequence. What's the next element of the sequence? I hope that all of you can get this right. What's the next element of this sequence? 1/6. Good. Now, is this arithmetic, geometric, or neither? It's neither. It's neither. People say neither or neither?
Neither.
Then which one do you say? Okay, why not arithmetic? Why not arithmetic? Well, you're not really from 1/2 to 1/3. What do you add from here to here to get what do you add from 1/2 to 1/3 to get this, you know? Well, whatever you add, there's no constant c that you add it here, you add it here, you add it here, and you get the next term. There's just no element like, there's no number like that. Couldn't you do 1/n plus 1? I mean, 1/n plus 1, that's a sub n, yeah. So a sub n will be 1/n plus 1. That's the general term of the sequence, but that's not, just because you can find the general term of the sequence doesn't mean that it's arithmetic, right? You need a number that when you add it, you get the next element. And there's no number that you add to 1/2 to get 1/3. That will also get you to 1/4. You know, if you put it in decimals, it'll make more sense. So this is 0.5, this is 0.3, repeating, this is 0.25, this is 0.2, right? So from here to here, you subtracted off 0.17, let's say. From here to here, you subtracted off how much? 3.8, right? Or thereabout. And then from here to here, you subtract off 0.5. So each time you're subtracting off a different amount. Right. All right. So, okay, good. What's next? Graph the following. So we'll do this one together, and then I'll give you another one that you do by yourself. Oh, sorry, let me do it this way. Okay, so first question, is this a hyperbola or an ellipse? Anyone? It's a hyperbola or an ellipse?
Ellipse.
Yeah, it's an ellipse. Good. And what's the center? What's the center of this ellipse? Well, hopefully you can see that the center is 2, 3. Hopefully that's not too hard to see. So 2, 3. Okay, fine. And here this is saying my A is equal to 5. So A is equal to 5 because, you know, it comes from here. A is equal to 5. That means that the horizontal distance of this ellipse is going to be 5. Now, if that's true, that means that this point here is 7, 3. This point here is minus 3, 3. I hope I got that right. Yeah, that looks right. And my B here, that's equal to 10. So that means that the height of the ellipse is going to be equal to 10. I got that from here, right? This is B squared, this is A squared. So if B is equal to 10, these points, what do they have to be? Well, this is going to be 2, 13, and this is going to be 2, -7. Then you just connect everything up. Doesn't look like a very good ellipse, but you know, so that's what it looks like. Not a very handsome ellipse, but there it is. So now I'll ask you to do the following. You graph this one. So this was 1. Now graph number 2. I'll give you about 3 minutes for this one. Should be a plus. Okay. Try to graph this thing. I'll give you about a minute for this one. Okay, so hopefully we're able to get it. What's the center? 3 comma minus 4. Good. So let's draw that. 3 comma minus 4. So 3 stays out here, minus 4. All right. So actually, I'll do it a little. There you go. 3 comma minus 4. All right, fine. And so what is my A value here? What's the horizontal distance? A is equal to 6. Good. Right? A is equal to 6. So that means that these lengths will be 6. Okay. So what does that tell me? That tells me that this point here, if I add 6 units, that's going to be 9 comma minus 4. And this point here is going to be minus 3 comma minus 4. All right. Fine. Then my B value is equal to 4. I hope that's clear. So if B is equal to 4, it means the height is going to be 4 for each one. Oh, hold on, I messed up. Okay. That means this point here is 3 comma 0, and this point here is 3 comma minus 8. Good. So connect everything up. This is what this guy looks like. All right, so did everybody get this? Yes, good. Good. How many people do I have? Oh, it looks like more people found their way in. That's nice. By the way, I was looking at my YouTube on Netflix, which is my YouTube channel, and only 20 or so people watched all of the videos, and that made me very sad. So I think you guys really need to watch those videos. At first I looked at it and I said, oh, 20, that's not bad. 20 million views, not too shabby. But then I checked and it's just 20. Can you believe it? People aren't watching pre-calculus videos. Okay.
Some of us don't have an account, so like you watch it and it doesn't count as a view.
Oh, wait, that's not how it works. Even if you don't have an account, it'll count as a view.
No, I don't think so.
What? Who told you that? Okay, that's interesting. I'll Google that later. A view is a view, exactly. All right, wait a second here. All right. Okay, let's see. Okay, so this is a pretty tough question, but I want to see if you guys can do it. So we'll do this one together, and then I'll give you another one to do. So find, hello, all right. Find the sum of this -3 plus -12 plus -48 all the way up to -3072. Okay. So for this one, I want to find the sum here. Let's recall the nth partial sum of a geometric. This is a geometric sequence. That's the first observation. This is a geometric sequence. I'm multiplying by 4 to get to the next term. So please take note, this is a geometric sequence. All right, so S sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. Okay. So I know what a sub 1 is, but I don't, and I know what r is, but I don't know what n is, right? So I know this is, so if I were to plug in what I know, Okay. So that's what I know. But I don't know what n is. In order to find this partial sum, I need to know what n is. So this is the first term, second term, third term, and this is the nth term. But what is n here? Well, okay. I know that a sub n for a geometric sequence is given by a sub 1 times r to the n minus 1. So that means that a sub n is minus 3 times 4 to the n minus 1. And so since this is my a sub n here, this guy is my a sub n, I'm going to plug that in. I'm going to say minus 3072 equal to minus 3 times 4 to the n minus 1. Okay, you divide by 3 on both sides. This should be 1024 equals 4 to the n minus 1. You could do log here to solve for n, or you could just do what I do, which is I just count by 4s. 4, 16, 64, 128. No, that's doubling. This is 256. And then it's 1024. Okay. So this is 1, 2, 3, 4, 5. So that means 1024 is equal to 4 to the 5. Oh, so that tells me that n minus 1 equals to 5. So n is equal to 6. Okay, so my n is 6. And so I can go back here and plug everything in. So here this turns into s sub 6 is minus 3 times 1 minus 4 to the 6 all over 1 minus 4. And if you plug that into the calculator, actually, what do you get? You get 1 minus 4 to the 6. But what is that? Oh, where did my calculator go? Darn it, I lost my calculator. Can somebody put this into their calculator? You should get minus 4,000 and something. Minus 4,047? Is that it? No. Can somebody put this into their calculator? This will cancel with this will cancel. So you're just doing 1 minus 4 to the 6. Oh, I could do that though. That's 2048. Yeah. Minus 4095. That's the answer. Okay. Is that clear? How we got that? So now I'll give you another question to do.
Wait, so how does the negative 3 and the 1 minus 4 on the bottom cross out?
1 minus 4 is negative 3.
Oh, okay.
Quick question. Where did the S sub n equations come from? Well, I didn't prove them if that's what you're asking, but this is from the YouTube video. So if you look at the YouTube video, I actually proved this, I didn't prove it, but I gave this to you, 2 weeks ago. This is the nth partial sum. So this is the nth partial sum of a geometric sequence. This is the nth partial sum of a geometric sequence. Okay, Sanjita? That's just a formula that you need to know. You need to have it memorized. So, okay. Next, I want you to find this sum. No, let me do it this way. Please find this sum. And while you do that, I'm going to go find my calculator. I'll just use my phone instead. Give you an, I'll give you another minute or so on this. Please make sure that you try it. Mathematics is not a spectator sport. Okay, so let's try this question together. I know that S sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. What is my r here? This is I'm obviously assuming this is a geometric sequence. If this were an arithmetic sequence, we would use the formula for that, which is different. And I think I have a question here where we will use that later. Okay, so let's just plug in everything that we know. So this is telling me that S sub n is equal to, my a sub 1 is 4 times 1 minus 2 to the n all over 1 minus 2. Okay, fine. But here, what is my n? I need to know what is my n here. So this is my first term, this is my second term, this is my third term, fourth term. This is the nth term. What term is that? Well, okay. I know that a sub n for a geometric sequence is a sub 1 times r to the n minus 1. And this I did prove, I derived this. So this is telling me a sub n is equal to 4 times 2 to the n minus 1. So I'll just plug in, I know this is a sub n. Plug that in, 2048 is equal to 4 times 2 to the n minus 1. And what is that? So this is telling me that 526, no, 520, hold on. I'll just use my calculator to do this. Typically I can do those calculations, but when I'm sick, that's my excuse, I'm sick. Let's see, so this is 512, okay. So this tells me 512 is equal to 2 to the n minus 1. And you could do logarithms if you wanted to. That's probably the smart way to do it. I like to count by 2. So 2, 4, 8, 16, 32, 64, 128, 256, 512. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 2 to the 9. All right, and that's telling me n minus 1 equals 9. So n is equal to 10. Okay, so S sub n is equal to, so S sub 10, which is what we're trying to compute, is 4 times 1 minus 2 to the 10 all over 1 minus 2, which is, what is 2 to the 10? That's 128, no, 1028, right? No, 1024. So 1 minus 1024, and then times 4. So this is 4092. So once you do all those calculations, you get 4092. So this is 4092. And yeah, I believe that. That seems right. Okay, any questions on this? Did everybody get 4092? Can you go over the last step? Well, the last step is just plugging everything in. I know that this is the 10th term, so I just plug in s sub 10 is 4 times 1 minus 2 to the 10 all over 1 minus 2, and I put this in my calculator because I don't want to think, and I get 4,092. Was that the last step that you wanted me to go over, Jesus? Okay. Yeah, you just 4,096. You got 4,096. That could be right. Maybe I did it wrong. Let me check. Let me actually put it into my calculator. 1 minus 2 to the 10. That's 1023 divided by 4. Multiplied by 4. I don't know. It says I'm right, but so double check, Jesus. Just double check. Okay. All right. So let's go on to the next. Let's go on to the next question. Do we have to do it with the sum and difference equation? What do you mean? Do we have? Yes. Okay. Yeah. You can't just plug it into your calculator. You can't just plug in these numbers into your calculator. You can't just do 4 plus 8 plus 16 plus 32 plus blah, blah, blah in your calculator. If you did that, you'll get some points for the right answer, but you won't get full marks. Okay, Miriam, you can use that to check your work. But yeah, very, very good question. All right, so 11 factorial over 9 factorial. How do we do this? Well, at first it seems bad, but it's actually not. So this is 11 times 10 times 9 times 8. I'm just going to keep going here. This is 5, 4, 3, 2, 1. All over 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then you just make these cancellations. This is really fun to do. So then at the end of that, once the dust settles, you get 11 times 10, which is 110. This is number 1. Let's do number 2. Let's say 7 factorial all over 5 factorial. What is this going to be equal to? Well, again, you just do 7 times 6 times 5 times 4. 3 times 2. You just unravel the top and the bottom and you make the necessary cancellations, right? Seven times 6, what is that equal to? What if the number is like, okay. Yeah, Maria, we'll go over that question. That's a great question. So 7 times 6 is, what is 7 times 6? 42. Thank you. So bad at math. Okay, Maria's question is, what happens if you have really big numbers like 102 factorial over 101 factorial? Well, you don't have to write everything out, but it is, just draw a picture for yourself of what this might look like. So this is 102 times 101 times 100 times blah, 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 3 times 2 times 1. Okay. And on the bottom, you have 101 factorial, which is 101 times 100 times blah, 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 3 times 2 times 1. Well, if you think about it, you can do the same thing. You're making a lot more cancellations, but you're just doing cancellations. So 101 will cancel with 101. 100 will cancel with 100 down here. Everything in between will cancel with everything in between. And at the end, everything will cancel. So you're just left with 102. Is that clear? Good question, Maria. Now, here's the last one I wanted to go over. If you have 3 factorial over 0 factorial, what will this be equal to? 3 factorial over 0 factorial. Well, 3 factorial is 3 times 2 times 1. That's simple enough. 0 factorial is 1. if you recall. If you haven't seen that video yet, you should go watch it. That's the very last video about binomials and factorials, I think. But you should watch all of them. You should just watch all of them from beginning to end, that whole playlist. So, the ones obviously cancel, but one always cancels. This is 3 times 2 times 1, which is 6. So the answer is 6. If this if it wasn't factorial, then we'd be in trouble. We can't divide by 0. But 0 factorial is 1. Okay. Let's see what else. 5. Okay. So I would like you guys to do this question. I'll give you a few minutes, and I'll give you 1 minute to do both of these. So I want you to expand. Here, I'll write this. Expand the sum. So expand these, please. Maybe about a minute. You don't need more than that to do this question. If you know what everything means, it should take you about 30 seconds. Okay, so let's go over this. For number 1, to expand this out, well, this is just equal to, you start at 1, remember, you plug that in, 1 over 2 to the 1, plus increment 1 over 2 to the 2, plus 1 over 2 to the 3, and since 3 is the limit, that's where we end. You could simplify this, you could say it's 1/2 plus a 4th plus an 1/8. You don't have to. Okay, so that was number 1. Number 2, again, you start at here, instead of starting at 1, you're starting at 7, so you just plug that in. So this is 3 times 7 plus 7. Increment that, so now you're at 8, so 3 times 8 plus 7, and plus 3 times 9 plus 7, plus 3 times 10 plus 7. And again, you could simplify this. This is 28 plus, let's see, 16, 24, 31, plus 34, plus 37. You could simplify it, but you don't have to. And I'm not asking you to compute this, I'm just asking you to write out the sum, expand the sum. Okay, did everybody get this? Okay, great. What's next? Let me just look at my notes here. Okay, so now I would ask you something like this. I would ask you something like this on the exam. Find the sum of this thing from I equals 30 to 80 of 3i. Okay, so I'll show you how to do this question, and then I'll give you one to do for yourself. All right. So this, if you were to expand this out, what does this look like? This looks like 90 plus 93, sorry, plus 96 plus all the way up to, where do we end? 3 times 80. Well, we're going to plug in I equals 80. That'll be our last term, which is 240. Good. Good. Okay, so how will I find this sum? We could use the little Gauss method, but maybe we should be a little bit more systematic. I know that S sub n is A1 plus AN over 2 times n. I know this is my A1. I know this is going to be my AN, but I don't know what AN is. Well, okay, fine. I know that A sub n is A1 plus D times n minus 1, because this is an arithmetic sequence. So A sub n here is 90 plus my common difference is 3. Okay, so this is the general term of this. A general term of the sequence will look like this. It'll be 90 plus 3, you know, how many times? N minus 1 times. And A sub n, I'm looking for n here. I don't know what n is. So I'm going to plug in 240 for my n, for my A sub n rather, to find n. So this tells me 240 equals 90 plus 3 times n minus 1. If I subtract 90 on both sides, I get 150 equals 3 times n minus 1. So this is telling me 50 equals n minus 1. So n equals to 51. So this is actually my 51st term. If this is the first term, second term, third term, this is the 51st term. And so plugging everything in now, this is telling me S sub n is 90 plus 240 all over 2 times 51. And you plug that into your calculator. And let's see, I'll race you. I got 8,415. Is that right? $8,415. Is that what everybody else got when they plug this in? Good. So that's the answer. That's the answer. If you take all of these numbers and you add them up, you'll get 8,415. Yeah, that makes sense. I'm okay with that. Okay, so is this clear? Are there any steps that I should discuss more before I give you your own problem to try? Okay, so here's a question for you to do. Find this sum. Hold on, let me just look at my notes here. No. I don't like that question. Let me give you this one. Okay, so do this question. Actually, I don't like this, so here. N equals 10 to 50. That's better. So do this question. Actually, this should be an I. So I, it doesn't change the question, but I equals 10 to 50 of 3i plus 7. So I'll give you about a minute or two for this. Does anybody want more time? Okay, well, let's go over this one. So I like to expand this out just to see what I'm working with. If you plug in 10 here, you get 37 plus next one is going to be 40 plus 43 plus blah, blah, blah. And the last term is going to be 150 plus 7. So 157. Okay. So I know that S sub n is going to be a sub 1 plus a sub n all over 2 times n. I know what a sub 1 is, and I know what my a sub n is, but I don't know what n is. So I need to figure that out. Okay, fine. I know that a sub n is a sub 1 plus d times n minus 1. Here, hopefully you can tell that d is 3. So a sub n is equal to 37 plus 3 times n minus 1. My a sub n is 157, so that's how I'll find what n is. So this is 120 equals 3 times n minus 1. So 40 equals to n minus 1. So that says that n is equal to 41. Okay, n is equal to 41. So this is my first term, my second term, my third term. This is my 41st term. And so when you plug that into here, so S sub 41 is equal to 37 plus 157 all over 2 times 41. Let's see. I'm going to put this into my calculator. And that is 3,977. Okay. Is that what everybody got? Did anybody get that? Yes. Can you explain how d is equal to 3? Well, d is equal to 3 because this is an arithmetic sequence. And to get from this term to that term, you're adding 3 each time. Okay. If you just expand out, Sanjita, for the first few terms, you'll see that this is, I mean, how else do you know to use this one, right? This, this thing here is the nth partial sum or arithmetic sequences. Okay. Oops. All right. One more on the topic of sums, and then we'll call it a day for sums, and then we'll go on to the binomial theorem. So let's see. Yeah. Write in sigma notation. So if I gave you something like this, hold on. I want you to write this in sigma notation. Well, I'll do the first one, and then I'll give you another one that you do. So here we go. I know that, so I want to write this in sigma notation. So this is going to be the sum of, well, let's see. What am I taking the sum of? This is an arithmetic sequence. Hopefully you can see that. I'm adding 3 each time. Sorry that I'm adding 3 each time. I'll try to give more variety. But I'm adding 3 each time. And so that tells me that a sub n is equal to, my a sub 1 is, well, here, I'll just write out the general form. So this is telling me a sub n is 12 plus 3 times n minus 1. So I'm summing over this thing. Okay, I'm summing over that. Where my n, I'm starting off at 1. This is my first term, my second term, my third term. And then what am I ending at? What term am I ending at? Well, to find out what n is, I can just plug in 312 for a sub n and solve. So this is telling me 300 is equal to 3 times n minus 1. 100 equals n minus 1. N equals 101. Okay, so that's the answer. This sum, you can rewrite it like this. All right, is that clear? Now I want you to do this one. 5 plus 12 plus 19 plus all the way up to 355. Hope that's right. Yeah. So write in sigma notation. I'm not asking you to compute this. I'm just asking you to write this in sigma notation. So I'll give you about a minute to try this question. Write in the chat when you think you have the answer. Anybody? Nobody has the answer yet? Okay. Okay, let's go over this one. Let's see. So what am I summing over here? Well, I know that a sub n is equal to a sub 1 plus d times n minus 1. So that means a sub n is equal to 5 plus my common difference is 7 here times n minus 1. You could simplify this down, but you don't have to. So I'm just gonna put it in like this. Okay. And then what am I summing over? So obviously I'm summing over, I'm starting at the first term, then I want to add up the second term and the third term and the fourth term and so on and so forth till I hit up to here. But what term is this? Well, I could just plug this in for a sub n and solve for n here. So this tells me that 350 equals 7 times n minus 1. So that means 50 is equal to n minus 1, n equals to 51. So I'm summing up 5 plus 12 plus 19 all the way up to, this is the 51st term, 355. So when I expand this out, I should get 5 plus 12 plus 19 plus 350 plus all the way up to 355. And that actually works. If you plug in n equals 1, the first term you'll get is 5. If you plug in n equals 2, 5 plus 7 times 2 minus 1 is 5 plus 7, which is 12. And then and so on and so forth, so on and so forth. And when you plug in 51, you will actually get 355. So that works. Okay, so this is the answer. Did everybody get this? Or did anybody get this? Yes. Okay, great. Great, great, great. All right, so now, final topic, we'll talk about the binomial theorem. Binomial theorem. If you didn't watch the playlist, you should, the lost lecture, lecture 25, then you should. It's on YouTube. You should watch it now. This review won't help you very much unless you watch this. You watched it. So go watch that, and then later on, I'm going to post these on YouTube. Oh, by the way, I should make one announcement. I'll have extra office hours. Here. Note. I'll have extra office hours on Tuesday and Wednesday at 12. Okay, so we'll be able to meet on Zoom around 12. Does anyone think they'll come, by the way, to this? No, nobody? That's fine. Wednesday, maybe. I will. Okay.
I have class.
All right, sorry. So yeah, Tuesday and Wednesday at 12. You can come with your questions before the exam, and we'll discuss. All right. So on to the binomial theorem. So the binomial theorem says that x plus y to the n is going to be equal to the sum I equals 1. No, let's say k equals 1. No, k equals 0. N choose k, x to the n minus k, y to the k. Let's see an explicit example of this. X plus y to the fourth, according to the binomial theorem, is the sum from k equals 0 to 4. 4 choose k, x to the 4 minus k, y to the k. All right. So let's see. Let's expand this out. So if you I go very slow when I expand these. So k is equal to 0, That means 4 choose 0, x to the 4 minus 0, y to the 0. Then you increment it. 4 choose 1. Now my k is equal to 1. 4 choose 1, x to the 4 minus 1, y to the 1, plus 4 choose 2. 4 minus 2, y squared, plus 4 choose 3, x to the 4 minus 3, y cubed, plus finally 4 choose 4, x to the 4 minus 4, y to the 4. All right. So now you might be worried, oh, I have to compute 4 choose 0, 4 choose 1. But if you remember, we can just use Pascal's triangle here to get these values. And again, if this is, if you didn't watch the YouTube video, this all looks like black magic to you, but otherwise, hopefully this seems familiar. So we go to the fourth row, to row 4, and that tells us, okay, so here, I want to do it this way. So 4 choose 0, we know is going to be 1. 4 choose 1 is going to be 4. 4 choose 2 will be 6. 4 choose 3 is 4. And 4 choose 4 is 1. So when you plug everything in, you get 1 x to the 4. Y to the 0 is just 1, so I'm not gonna write that. Plus 4 choose 1 is 4, x to the 3, y to the 1, plus 6, x squared, y squared, plus 4, x to the first, y cubed, plus 1, x to the 4 minus 4 is 0, y to the 4. Sorry, x to the 4 minus 4 is x to the 0, which is 1. So I'm not going to write that. Okay. So that's the answer. So this was hopefully a review on the binomial theorem. Let's do another example. Is everyone okay with this? How many people actually watched that video? Hold on, I want to check this. Let's see. I'm checking now. Only 20 people watched my binomial theorem video. There's 70 people altogether in the entire, well, it doesn't matter. Well, it does matter, but there's no use getting worked up over it. Okay, let's do 3x plus 2 to the 4th power. Well, let's do it 3rd power, right? Typically, you'd have to do 3x plus 2 times 3x plus 2 times 3x plus 2, but with the binomial theorem, you don't have to. The binomial theorem says that x plus y to the n is going to be this thing. And you do have to memorize this. Okay, so by binomial theorem, 3x plus 2 to the 3 is going to be equal to the sum from, let me make this sigma better, k equals 0 to 3 of 3 choose k. What is my x here? My x is actually 3x, and my y is 2. So this will be 3x to the 3 minus k, y, and my y is 2, so 2 to the k. Does everybody see how I made those substitutions? Is everyone okay with that? Any questions? No questions? Okay. All right, so now let's just plug everything in. K is starting at 0. 3 choose 0. 3x to the 3 minus 0, 2 to the 0, plus 3 choose 1, 3x to the 3 minus 1, 2 to the 1, plus 3 choose 2 of 3x to the 3 minus 2, y squared, plus 3 choose 3, x to the 3x to the 3 minus 3, 2 to the 3. Okay. And now to compute this, we just use Pascal's triangle. And remember, I say this is the 0th row. This is the first row. This is the second row, and this is the third row. Or I use the cardinal. So I say this is row 0. This is row 1. This is row 2. This is row 3. So since you're doing something to the third power, you'll go up to row 3. All right. And so we know that 3 choose 0 will be 1. 3 choose 1 will be 3. 3 choose 2 will be 3. And 3 choose 3 will be 1. So you plug everything in, you get 1 times 3x to the third. Should I just leave that like that? No, I'll expand. So 3x to the third is 27x to the third. 2 to the 0 is 1, so I won't write that. Actually, let me just write that so it's clear. 3 choose 1 is 3. 3x squared is 9x squared. 2 to the first is just 2. 3 choose 2 is 3. 3x to the 1, y squared. Oh, this y squared should have been a 2 squared. Excuse me. So 2 squared is 4. And then 3x to the 3 minus 3 is 1. And then 8 is 2 to the third. So now you can put everything together. Oh no, this is, so 3 times 9 times 2 is 54 squared plus 9. So 3 times 3 times 4 is 36. And then plus 8. Okay, so that's the answer. You'll notice I go really, really slow. I go step by step, and I recommend that you do it that way as well. Is that clear how I did this question here?
Hey, can you explain the 1331 thing?
That's Pascal's triangle. What do you mean explain it? What do you need explained?
Allow me to impress
Like
the severe mistake you have made.
like how we know like which one is which?
Oh, okay. So 3 choose 0. 3 choose 0 is, so the way I do it is you always start counting at 0, right? So you go 0, 1, 2, 3. Okay. And then 3 choose, so you're on the third row, and then you want the 0th element. What's the 0th element? Well, again, you start counting at 0. So this is 0, this is 1, this is 2, and this is 3. Okay. It's all in the YouTube video. If you don't want to use that, how can you solve it? Well, Miriam, you could actually compute these. You could figure out what is 3 choose 0. Remember n choose k, if you watch my YouTube video, is n factorial all over n minus k factorial, k factorial. So, for example, I'm just going to do an example. 3 choose 1 is 3 factorial all over 3 minus 1 factorial, 1 factorial. 1 factorial. And then you can just expand this out. This is 3 times 2 times 1 all over 2 times 1 times 1, which is 3. And you would get the same answer as you would have gotten before, right? 3 choose 1, as we said here, is 3. Okay, Miriam? So you could do it that way, but I don't recommend it. Again, if you didn't watch the videos, this probably looks like black magic to you. I don't want to spend too much time on it because you have to watch the videos to understand it, but and then you can just go back to this recording.
I'll watch the videos.
Okay. All right, so one more question, and then I think we can call it a day. Find the third term in 3x plus 1 to the 4th. Okay. Well, I did an example like this at the end of that last video. After this, can you go over hot dog, corn dog, and vertice stuff? Yes. So find the third term in this sequence. So the third term is the 2 plus 1 term. So if you remember, recall, actually, let me just do it this way. Let's do this one for now, and then we'll do that one later. Recall, the r plus 1 term in x plus y to the n is given by n choose r, x to the n minus r, y to the r, right? So if I want the third term in x plus y to the 4th, I know that that's going to be 4 choose 2 x to the 4 minus 2 y squared. And 4 choose 2, what is that? Well, I'm going to use my Pascal's triangle. Four choose 2 is, let's see, 0, 1, 2. That's going to be 6 x squared y squared. So this is the third term in the sequence. In this expansion, this would be the third term. Okay. Is everyone clear on that? How I got that? Yes, no? Should I do another example?
Yes.
Are you watching cartoons there? What's going on? Anyhow, let's see. So why is it that the r plus 1 term, you have to use r instead of just r plus 1? For example, why did I have, if I wanted the third term, why did I have to use 2? Right? That's a question you could ask. And the answer is, let me just do an example. Oops.
Can you go back to the previous slide so I can take a picture of it?
Take a picture. You should be taking notes.
I am, but you went too fast.
Okay, so am I going too fast? I'll slow down. A bit too fast. Okay. Okay, I'll slow down a bit. So here, let me just give you this example, and then I'll go back. X plus y cubed. If I were to expand this out, I'm just going to give you the expansion. I'm not going to do the calculation. This expands out to be this. Actually, I will do the explanation. I know that this is going to be the sum from k equals 0 to 3 of 3 choose k, x to the n minus 3 minus k, y to the k. That's by binomial theorem. And when you expand this out, this is what you get. Yeah. Let me do it this way. Okay. Plus blah, blah, blah. All right. So when I want to find the nth term here, this is the first term, but I had to use 3 choose 0. This is the second term, but I had to use 3 choose 1, So, and for the fourth term, I'm going to have to use 3 choose 3, x to the 3 minus 3, y to the third. Okay. So for the rth term, for the r plus 1th term, I'll have to use r n choose r, x to the n minus r, y to the r. Does this make sense now? Why it's like this? Anyone? Well, okay, just do a million billion problems. And it'll make sense. So let's do another example. Find the second term. Find the second term here. Okay. So I know that the second term, that's the 1 plus 1th term. So I'm going to be using, and since my n is 4 here, I'm going to be using 4 choose 1, x to the 4 minus 1, y to the 1. Is that clear? If I'm using 2, I'm going to be using, if it's 2, then I have to use 1. If it's 3, I have to use 2. It's r plus 1, I have to use r. Okay. What's my x here? My x is 3x. And my y is 1. So this is my x, and this is my y. So I'm going to plug that into here. This is 4 choose 1, 3x to the 4 minus 1, y to the 1. Okay, so 4 choose 1 is, if you were to do it out on this triangle here, that's going to be 4. 3 to the 3x to the 3 is 27x cubed, y to the 1. 4 times 27 is, let's see, 4 times 27 is 80 plus 21, which is 101. So it's 101 x cubed y. So if you were to expand this out, if you were to figure out what this expands to, the second term would be this guy. Is that clear? Yep. Okay. Should I do another example?
Yeah.
Okay, one more example. Hmm. Okay. Oops. hold on, sorry. Let me just. Okay. Why won't this? All right, now it's working. So find the third term in 2 plus b to the 5th power. 2 plus b to the 5th power. Find the third term. Okay. Well, the first thing I'm going to note is I know that the third term is the 2 plus 1 term. So my r is going to be 2 in this case. So I know that the term I'm looking for is n choose r, x to the n minus r, y to the r. All right. So I'm going to plug in everything that I know. I know my n is 5, my r is 2. My x, what is my x? My x is 2 in this case. Yeah, my x is 2 in this case, so it'll be 2 to the 5 minus 2. And my y is b. So this is just going to be b to the 2nd power. All right. Now all I have to do is compute 5 choose 2. What is 5 choose 2? Well, I'm going to go to row 5. What did you write under the third? It says 2 plus 1. This is the 2 plus 1th term. Okay, so 5 choose 2 is, remember, this is my 0th. This is my, this is row 0, this is row 1, this is row 2, this is row 3, this is row 4, and this is row 5. And 5 choose 2, this is 5 choose 0. 5 choose 1, 5 choose 2 is 10. So this is 10 times 2 to the 3rd b squared, which is just 80b squared. So if you were to expand this out, what you'd get in the third term, that would be 80b squared. Okay. And if you forgot how I got this Pascal's triangle, you just do this. You do 2 plus 1 is 3. 3 plus 3 is 6. To get the next term, you just add the 2 above it. And on the sides, there's always just 1s. 6 plus 4 is 10, for example. Right. Okay, so hopefully that's clear. Hopefully for those of you who haven't watched that playlist, hopefully you'll watch it. Variable is b squared, yes. So here, this is the r plus 1th term is going to be this. So that means that the 2 plus 1th term will be this, right? I want the third term, but that's the 2 plus 1th term. Again, if you didn't watch those videos, this is going to be really confusing. So there's no point in scratching your head and trying to understand it now. You do have to go back and watch those videos. Okay, so I think that's it. I think I'm going to stop recording now.